Hi. Today, I'm going to talk about synthetic division, a real quick shortcut to the painful, long, polynomial long division you've probably been used to using. Using synthetic division, we can make our jobs dividing polynomials much easier. We can simplify it down to simply adding, subtracting, and doing some basic multiplication. Real easy stuff. And in a nice, neat formula that you can use in almost any quadratic or any polynomial division you come across. So, let's go over what synthetic division is. Let's do a counterexample, right? Say I was given something like this. X minus 1, and then we're dividing x squared plus 5x plus 6 by x minus 1. What does that look like? Well, first I need to have an x because I have an x squared here. So I'll multiply this by this, get x squared minus x, right? Because in order to make this x an x squared, I'm going to need another x. I subtract that, I get 5x plus x, so I get 6x plus 6. In order to get 6x, I'm going to have to multiply x by 6. That's a plus 6 here. I get 6x minus 6, I subtract that. I get 6 minus a negative 6, which is actually 6 plus 6, or 12. So my answer is x plus 6 with the remainder of 12. It's a lot of work and a kind of annoying answer. Synthetic division makes that a whole lot easier. So what does it look like? Well, first, our symbol for representing it kind of looks like an upside down division symbol. We have basically something like this. Right? First, we write the coefficients, that is the numbers next to the x, of what we're dividing along the top here. So in this case, we're dividing x squared plus 5x plus 6. Well, that has coefficients 1, 5, and 6. So we're going to write them like that. Next, we're going to put our test, the thing we're dividing, x minus 1. We're going to take this and basically put the negative version of that. So we're going to have 1 here. Because what we're basically saying is, if this x minus 1 divides evenly by x squared plus 5x plus 6, it's a factor, right? We call things that divide evenly factors. So we have x minus 1 is a factor of this quadratic. What does that mean? Well, if it's a factor, that means it's a solution. We usually find solutions by setting them equal to 0. So in this case, if x equals 1. What this synthetic division test is not only just a test for polynomial division, it's a test to see if things are factors of others. Right? If x equals 1, comes out and has no remainders, we know it's a factor. So we're not testing the entire term. We're testing this final ending value, right? Is this a factor of this? Let's carry on though. We're going to take the first number inside, this 1, and bring it down, just like this, right? Then we're going to multiply this value by our test value and write it up here. Now, we're going to add down the column, so we have 5 plus 1, which is 6, and 6 times 1, 6 plus 6, which is 12, right? Now, we're going to rewrite this quadratic with our coefficients, right? So we have in our x column, we have 1. In our units column, we have a 6. Then we have a remainder of 12, which is exactly what we got when we divided previously. All right? Let's do another example to make this a little more clear. Say I have something like this. X squared plus, 5x plus 6 divided by x plus 3. What does that look like? Well, I'm going to take it, write our coefficients of this along here. So that's 1, 5, and 6. We're going to take the negative version of our ending term here. That's negative 3. We're going to bring this 1 down, multiply this by this. That's negative 3. We're going to add our way down. 5 plus negative 3 is 2. 2 times negative 3 is negative 6. adding all the way down, we have 0, right? We have, this is our x column, this is our units column, and this is our remainder column. So we have 1x and 2, and a remainder of 0. What is this saying? Well, it's basically saying not only is x plus 3 a factor, like so that as a remainder of 0, but when we multiply together by x plus 2, we get x squared plus 5x plus 6. And this is where synthetic division is pretty nice. Not only, once you get used to it, is the process pretty simple. We're carrying down, we're multiplying, and we're adding. Real simple stuff. But we get to find not only, hey, is this divisible, but what's the other component, right? We basically get rid of the long, tedious process of polynomial long division. We have to find what do we have to multiply x by to cancel this particular term out. And then we have to do all the subtracting and the distribution. That's all gone. We just have to multiply and we have to add. Really, really easy. But that's all synthetic division is. I hope you found this helpful, and I hope you have a great day.